Charging Your Phone with Thermoelectric Energy by Michael Kim and Justin Yates.
During our experiment, we are trying to find out if we can charge an iPhone using heat. We use Peltier tiles. These devices use the difference in temperature on each side to produce electricity. To charge an iPhone, we will need 5 volts.
Before we start trying to charge our phone, we will need to attach a heat sink used to take heat away from electrical devices, using a thermal compound used to increase the thermal conductivity between heat sink and electrical devices. You need to squeeze the thermal paste onto one side of the device and spread it out. After it is all spread out, put the heatsink on it and push down hard. Give the thermal paste time to dry before testing. This is the multimeter. It is a tool used to measure voltage. During our tests, we were using it to measure DC voltage.
For our first test, we put the Peltier tile on the table to see how much electricity the tile would produce without being affected by any heat. We attached the 2 prongs on the multimeter to the wires on the Peltier tile. During this test, the tile produced 3.1 millivolts.
For our second experiment, we put our hand on one side of the tile to see how much electricity we could produce using body heat. You have to put your hand on the side of the tile opposite of the heatsink, or else this test won't work. One person has to put the Peltier tile on their hand while the other person attaches the multimeter to the Peltier device's wires. During this experiment, we got an average of 21.1 millivolts.
For our third experiment, we got a heater and heated up one side of the Peltier tile. We propped up the tile using a roll of duct tape and put the heater on one side of the Peltier tile opposite of the heatsink. We waited 1 minute for the heater to get to its hottest point, then attached the multimeter to the Peltier tile. For this experiment, we got an average of 152.5 millivolts.
For our fourth and final test, we used the same electrical heater, but made a cardboard funnel to concentrate the heat onto one side. The funnel was made by outlining the tile and making a line diagonally sticking out of each corner. Then we cut the shape out and folded it into the funnel shape we wanted. The end result was that it produced 242 millivolts.
Our goal at the beginning was to be able to produce 5 volts using any type of heat. In the end, we were only able to produce 1/4 of 1 volt, not even coming close to our goal.